Hello everyone, my name is Raghav, and today we are going to solve the problems from the recent Codechef contest. The name of the contest is Starters 90, and it happened today itself. And I was able to solve the first seven problems. Again I failed to solve the eighth problem, but anyways, we will solve these seven problems. And today I will try to make the video as short as possible, so we won't go in depth and we will talk only about the intuition and how to approach the problem, and will not focus a lot on the implementation part because that's something you can do on your own once you understand the logic. So for the first problem, like you can read the problem and here are the test cases. Once you read the problem, then unpause the video and we will solve it. So I hope that you have paused the video and tried it on your own. So let's see what the problem says, that we have been given a table which initially has R rows and C columns, and then E extra rows have been added. So we have to tell the total number of cells finally. So what is going to be the total number of cells we have in this? Let's see. Just imagine there was a table like this. It had a few rows and columns, and you added, let's say you added two extra rows. So the number of cells which would be added is gonna be equal to the number of rows, which is E, into the number of columns in each row, that is C. And the initial number of rows and the initial number of cells were R into C. So the total number of cells now is equal to R plus E into C. That's it. And we just need to print this. So in this problem, the inputs are R, C, and E. Uh, like just like that, I just took the inputs R, C, and E and then printed R plus E into C. And this problem got submitted. So that's it for this problem. And let's go ahead for the second problem. So this was again a really simple problem. The problem says that Alice likes all the numbers which are even and multiple of 7. So it means that the number should be divisible by 2 and 7, both of them, which like you can derive it and realize that it has been talking about all those numbers which are multiples of 14, and Bob likes all those numbers which are multiple of 9 and they are odd. It means that the number should be indivisible, like not be divisible by 2, and it should be a multiple of 9. And we have been given that there would be a number which we have, and we have to tell if Alice likes it, Bob likes it, or both of them don't like it. In case if Alice likes it, then Alice will take it to home. If Bob likes it, then Bob will take it to home. And if both of them don't like it, then Charlie will take it to home. And since Alice likes only the even numbers which are multiple of 7, and Bob likes those which are odd as well, so it means that there would be no number which is liked by both of them, because a number cannot be even and odd at the same time. So what we need to do is just take an input, like we will have an integer, we will take it input, and then we will say that if it is a multiple of 14, then Alice will take it. If it is an odd number, that which means that it is not divisible by 2 and it is divisible by 9, so it should be divisible by 9 and not by 2. So in that case Bob will take it, and if both of these conditions fails, then it means that Charlie will take it. So the code is gonna be something like this. We will take input of the number. Here we have multiple test cases, and in each test case you will take an input n, and after that you will check if it is divisible by 14 or not. If 14, then Alice. In case if it is not divisible by 14, then you will check if it is divisible by 9 and not divisible by 2. In case if this condition satisfies, then Bob will take it, otherwise Charlie. And this problem also got submitted. And then the third problem, this was supposed to be the fourth problem, I guess, but it was simpler than the third problem. That's why more people submitted this one. So in this problem, like you can just have a read, pause the video and read the problem, and then we will continue. So I hope that you have read the problem and tried it yourself. So like you just need to have an observation in this problem that you don't want to disturb the number of inequalities between two adjacent numbers, not here but here. You don't want to disturb this inequalities. Like what you can do is just replace all the ones by zeros and replace all the ones by zeros and the zeros by ones, and then in what will happen is that the number of like the score will remain the same because the number of inequalities will remain the same, and the new string will be different from the original string, and that's what I did. So just to show you the code, I took the like n as input, and then I took the binary string as input. It was given as a vector of integers, so I like contained all of them in a vector, and then after that I will like I said that 1 minus nums I, which means that if nums I is 0, then 1 minus 0 will become 1, and in case if it was 1, then 1 minus 1 will become 0. And I just print all of them and then a new line for the next test case. And that's how I implemented it. There can be different ways of implementing it. For example, you could have written like ones or nums I. I show you the one which I used, and I think the problem was pretty simple. You just need to observe this much. Let's go for the fourth problem. This was supposed to be the third problem, but like fourth problem was solved more than this. So this problem says that you have been given like you can first of all read the problem and then I will explain the problem in brief. So I hope that you have read the problem, and now like the thing which you had to observe was that the maximum value of n can be only up to 100. So if you just apply the brute force method, everything has been given. I think that you already know about AP and this stuff. You would have studied this in class 11th. So you just need to check for every triplet. And how can you check for every triplet? A really basic method is just iterate over the array with three loops, three nested loops like this. This is the brute force method, and you will check for each and every triplet. In case if a triplet is an AP, then you will print no, and um, if you have been using a template like mine, then you can just say return. And in case you have been writing your code just inside the main, then you could have created a variable, let's say something like bool flag. Bool flag is equal to false at the beginning, and you could have created a like here you would have said that flag is equal to true. Instead of printing here, you would have said that flag is equal to true, or you could have actually printed as well. And after that, you will just keep breaking out. As an example, you could have break out here, and then here you could have used the conditions like if flag is equal to true, then break. If flag, then break. And here it won't come because you are breaking here itself. And this will also do the same job. At least I think so. Let's try to submit it. Um, it seems like there is a problem in the change I have made. So let me see it first. If flag, then break. I'm printing only once, and I've been coming here only once as well. So it should work, I guess. No, it has not been working properly. So like, let me write the code once again for you. I've been writing it for the people. Like, let me use this here. Let me show you the normal code here. If you are not using a template, so how could have you wrote it? Nameplace std and int main, just return 0, and it has multiple test cases, so we will input it first. and then you will have multiple test cases. And in each test case, what the first thing which you have been taking input is the size of the array, and then an array. Here an array, and then for the array, you have to check if there is a triplet or not. So let's declare a bool flag is equal to false, and for like we will go in a loop. The second loop will start from I plus 1 because we want distinct integers, and the second loop is gonna be something like this. This is just a brute force method, and here we will check if I had created an array with ARR name. So if ARRK minus ARRJ is equal to ARRJ minus ARRI, in that case we will say that flag is equal to true and break, and here we will apply conditions like if flag then break, if flag then break, and here we will say that if flag then cout no, else cout yes, and let's try to run this time. I hope it works now. I have been showing this implementation because this was a really straightforward problem where you just need to apply the brute force. So in case if someone failed to solve this problem and has been watching my video to upsolve it, I am like expecting that he must have got stuck somewhere around here in the implementation part. That's why I wrote the code once again to just show the implementation in an easy way. In an easy way, this is the most like the cleanest implementation you can have, and it got accepted. So now coming up to the fifth problem. The first four problems were really simple, and now the fifth problem might disturb you a little bit. First of all, let's clear it. Yeah. Now you can have some time to read the problem on your own, and then I will discuss the problem statement in brief, and we'll discuss about the approach and intuition. So I hope that you have tried the problem on yourself. And in case if you didn't try this, then please go back, pause the video, and read the problem statement. Try to think about it on your own, what things have been coming to your mind, and after that, start watching the video from here on. So in this video, like in this problem, we have been given that what is a semi-palindrome, and this is not an actual term. It's been used in this problem. Like I don't think that this is an actual term. And then we have been given a definition for anti-palindrome, and then afterwards we have been told that we have been given a string of n lowercase letters only. It will contain only the lowercase letters. Like this is something which you need to remember. And then you can see that it has been asking that what is the like in one operation what you can do is change any of the characters in the string to any other English lowercase letter, and we have to find the minimum number of operations needed to make string s into anti-palindrome. And here are the example test cases which you can see. So let me show you the like what you can do in these example test cases. The first thing which like the example test cases have been made in such a way that they like the problem setters want you to observe from the test cases and realize what can be the different cases in this problem. It has been done so that more people would be able to solve the problem even if they don't really have any idea from the start. In the first test case, you can observe that if like both if there is a string of um, let's keep it in this manner that if the string which has been given is not a palindrome already, is not a semi-palindrome either. If this is already an anti-palindrome, then the number of operations is going to be 0, and this can be seen in this here as well. If the string is an anti-palindrome already, then in that case the answer will be 0. If the if all the characters in the string are already equal to itself, like there is only one character which has been occurring every time, then it will depend either it is an even length string or an odd length string. In case if the length, let me write it. So we have been given a string. It There can be two cases. Either it will be of odd length or of even length. Do you know, if there is an odd length string, if there is a string of odd length, let's say to be R A something like this, it is odd length. If there is any character which has been occurring odd number of times, then this can never be a palindrome. Any of its permutation can never be a palindrome if there is any character which has been occurring odd number of times. Because for if you place it anywhere, like if you place it here, then you must have the same character here as well. The character which of the same character here as well. And in case if a character has been occurring odd number of times, then you won't be able to match the other side. You won't be able to like it won't be able to become like a mirror. The other part won't be a reflection of the first part. This was for the even actually. I told for even. The case I told was for even. But what if it is odd? In case if I have a string which is odd and there is a character which has been occurring odd number of times, then what I can do is place it into the center and have all the other characters which have been occurring even number of times. Let's say if they were B, there is no problem as long as all the characters except one of the characters has been occurring even number of times. I can place a character here and the equal character here as well and make there would always be a palindrome permutation of the string which is a palindrome. So how can I make an even length string as an anti-palindrome? So if the string which you have been given is of even length, then there can be two cases. Either it would already be an anti-palindrome, which means that there would be at least one character in the string which has been occurring odd number of times, which has a frequency of odd length, or there can be a case when even string which you have been given is not anti-palindromic, it is semi-palindromic or palindromic, it doesn't really matter. In that case, what you need to do is just change any of the characters to any character which has not been occurring in the string. So, or if it is even occurring in the string but has been occurring even number of times, just change it. Let me give you an example. What can be the worst case? Let's not talk about worst case right now. Just simply give me an example. ABR RBA. If there is a string in which all of the characters have been occurring even number of times, then I can always place it in manner like this, where the first one is equal to last one, second is equal to last second, and so on. Now what I need to do is just change it to anything else. Let's say I changed it to A. Now this has been occurring even a odd number of times and this has been occurring odd number of times. A and R have been occurring odd number of times and I cannot handle this. We discussed this a little ago. So that's what you have to do for even numbers. Either the answer will be 0 if it is already anti-palindromic, or the answer would be 1 in case if it is a semi-palindromic. It doesn't matter if all of the characters are same or not. But in case of odd numbers, there can be three cases. The first case, when the given string is anti-palindromic from the beginning. So you don't need to do anything, just print 0. How would you check if the given string is anti-palindromic or not. For even, you require to have at least one character which has been occurring odd number of times. But in case of odd numbers, if one character has been occurring odd number of times, you can place it in the center. So here you need to have at least two characters which has been occurring odd number of times. And in that case, you can say that this is an anti-palindromic string. As an example, we had been given ABC. Here there are three characters which has been occurring odd number of times. So you cannot place it in any manner such that you will have a palindrome with the permutation of the string. So the answer is 0. There can be a case in something like this, ABA or maybe AAB, which can be permuted, like which has a permutation like this. So in this case, what you need to do is just like if you ignore the center character, the character which has been occurring at the center, the remaining string seems like a string which was even. So what you can do, like for the even length string, it is something like that, and we already know that we can convert it into anti-palindromic string by just changing one character, and that's what we will do here as well, and we can do it in one character. But would this always be true? No. Why? Because let's suppose if all the characters are same and it is of odd length. If you ignore this one and try to think that this is like AA, which was an even length palindromic substring, and just change it to let's say B, then what will happen is that it will become AAB, which can be written something like ABA, like the character which you change can be placed at the center and all others around it. So in this case, you have to apply the operation twice. In that case, you have to apply the operation twice. So if it is NT, then it is 1. If it is semi or palindromic already, it is 1, unless um, in case if all of the characters are equal value में 2 आएगा. So that's what I have written in my code. Um, I think I have to go into the submissions to view my code. I don't know, is it not showing it? Yeah, it is showing it here. Um, as a disclaimer, let me tell you that I wrote this during the contest, so it is not very clear. Like I had to write it as fast as possible. That was my priority at that time. So in this code, what I said was, first of all, I figured like I calculated the frequency of all of the characters, and then I said that I named it as edge case, in which it is basically checking if all the characters are equal or not. In case if all of the characters are equal, then I will check if it is odd length string or even length string. If the string is of even length, then I can just change any of the characters and it will become an like anti-palindromic string. So the answer would be 1. Otherwise, it would be odd length string. So the answer would be 2. And here we have been returning so because we have got the answer. In case if you're not really familiar with the template, then don't stress it out. Just and remember that like try to focus on the logic part. Implementation part is something which you can do on your own, and you should be doing it on your own even after watching the editorial. So in my code, what I did was first of all check if all the characters are equal or not, and handled it. In case if all the characters are not equal, then I'm counting the number of odd the number of characters which have odd frequency, and after checking it, I have been saying that in case if the string is even length, it has been checking if the n is divisible by 2, which means that it is even length, and it has one or more than one characters which have been occurring odd number of times. It means that this is already anti-palindromic, and I have been checking the same thing. Like if the number of odd here actually I could have like even if I don't write this thing, it would still do the same stuff. If I just check odd is greater than equal to 2 or not, I missed this during the contest. You can just check if this condition holds, then print 0 and return. Otherwise, check if the string is of even length, odd length, and there is only one character. Like this would always be true. Yeah. So these things would always be true. You could just write C out one here and handle. Like I wrote this during the contest, and at that time I didn't want to waste a lot of time while thinking. That's why I wrote each and every test, each and every case, even though it was redundant. Anyways, implementation part is something you can do out on your own. And let's go ahead. Let's do it. Um, the reason I've been doing it right now is because in case if someone was trying to solve this problem but failed during implementation part, so for that case, I'm going to implement it once again and in a cleaner fashion. Namespace std int main, just return 0. Does it have multiple test cases? Yes, it has. So here we will write in t, cint, while t minus minus, and it contains n, the length of the string. So we will take it as input, and then we will take the string as input. I've been naming it as s. You can name it anything you want. Afterwards, what shall we do? We like here we had taken two cases. Either it is odd, either it is even or odd. So let's do it. Before doing it, first of all, let's find the number of uh, let's do the thing of finding the number of characters which have been occurring odd number of times. So first thing first, an array, frequency array, and then let's take the frequency. So we will take the frequency by saying that freq s of I minus a plus plus. Um, let's explain this as well. So si is will give me the character the ith index in the string s, and like it would be written in the integer form. Like this is something I don't want to explain right now. You can search it on your own. Otherwise, it will consume a lot of time of mine. So the video will become longer if I do so. That's why I'm not explaining. Here we will count the number of odd characters, the number of characters which have been occurring odd number of times. So we can do it like this: odds plus freq I mod 2. In case if the character has been occurring even number of times, then this would be 0 and nothing would be added to odds. In case if the frequency of ith character, like here I is something like A, B, C, D, E, F, G, H. So if it would be odd number of times, then after taking modulo it with modulo 2, it will return something like 1, and 1 would be added to odds. And I would have the count of the number of the number of characters which have been occurring odd number of times. And if n divided by 2 equal to 0, it means that the string is of even length. Then I can check if odd equal to 0, it means that the string is the string is semi palindromic or already a palindrome. In that case I have to apply an operation, and that's why I will print 1. Otherwise I will print 0. Otherwise I will print 0. And what I will do next, I will just say that continue. What will this do is that it will come to the next iteration of the next test case basically. And here we would be coming to this line only if n is odd, the length of the string is odd. Then in that case, I can check if odds is greater than or equal to 2. It would actually never be equal to 2, I guess. It would be equal to 3 or 1, something odd. But anyways, we have been checking for 2 just to be safe. And in that case, I know that this is already anti-palindromic, and I can just simply print 0 and L and continue just to go to the next case. And in case it is not anti-palindromic, it means it is odd length, it is of odd length, and semi-palindromic or palindromic. So I need to check if it is equal or not. In case if it is equal, if all the characters of the string are equal, in that case I have to print 2, otherwise I have to print 1. So I will use a boolean flag, let's say to be true, and I will iterate to all of the characters in the string and check if si is not equal to s0. I could have actually started it with 1 here, but anyways, in case if it is not equal to 0, then flag is equal to false. This will tell me that the string is not having all the same characters, and I can break because I have already found what I wanted. And now I will say if flag, it means that all the characters are equal. I have to apply two operations. Otherwise, I have to apply only one operation, and that's it. So let's try to run this code now. After this, we would be solving two more problems, and the next, like the seventh problem, I won't be going into its implementation too deeply. Hmm, I have made a typing error somewhere. Yeah, it's here. In the sixth problem, we will discuss about the approach as well, and in the seventh problem, like in the sixth problem, we will discuss approach in the code as well, and in the seventh problem, we will only discuss the approach, and I will show you my code, but like I won't write the code once again. It's a little complicated, so if you don't know about it already, then you don't know, and in case if you know about the implementation, then that's really easy. We have been trying to submit the fifth problem, I guess. Yeah, we have been trying to submit the fifth problem. Let's read the sixth problem in the meantime, and we'll check if it gets passed or not. So you can pause the video and read the problem. After that, we will discuss it. So I hope that you have paused the video and read the problem. And in case if you haven't, then you can still do it. And yeah, by the way, last problem got submitted. And here you can read the problem and you can spend some time if you want. This is quite easy problem, but like I misunderstood this to be a hard problem or a harder problem and wasted a lot of time thinking about it. Though this is really easy problem, what you need to notice in this is something like, let me write it. First of all, let's clear all of this. And we have been given two things, n and m. This n is the weight in kg or whatever unit let it be. This is required. This is something which I require. I'm not writing the unit, sir. This is something which I require, and this is something which I already have. So I already possess. Let's call it as let's write it have initial or let's anything like you can name it anything. So this is something which I have, and what I can do is in case if n and m are equal. Uh, let's show you from here that these are the weights of apples, and I have initially m weight which I want, and like I'm not having a weighing machine. I am just having a machine like जिसमें इधर कुछ वेट डालोगे इधर कुछ वेट डालोगे और ये बताएगा कि इक्वल है नहीं है दोनों में, and then you can match it. So we have been given a few conditions in the problem. The first condition, the first thing basically is that if you have some weight which is m basically, then you can make two parts of it of m by 2 and m by 2. How would you make it? You can you have weight of m. You will place some weight on the left scale. You will place some of the weight, other part of the weight on the right scale. And when both of the parts will have the same weight, the machine would be balanced. And there you know that both of them would be m by 2 and m by 2 weight. So what it means is that I can convert a weight into two parts, two equal parts which are equal to m by 2 and m by 2. Once I convert it into m by 2 and m by 2, what I can do is compare this m by 2, compare this m by 2 here with n. If m by 2 is greater than n, then what I will do is I don't need this part. I will just uh, like keep dividing like I will consider this as my new m, this as my new m, and this will remain to be my required weight which I want more. And in case if m by 2 was less than n, then I already know that I cannot uh, ignore this part. I have to include this. Otherwise, I will have only m by 2 part left, which is less than n. And even if I take all of that part, I would still be unable to have like get n. That's why I have to include one of those parts and will divide the other one. So what will happen is that I will convert like n equal to n minus m by 2 and m equal to m by 2. I will do this and apply the same operation once again, which I had already been applying. And in case if m is odd, then I cannot divide it into two parts because m by 2 and m by 2 would not be integers anymore. And in the problem statement, I have been given that both of them should be integers. So, like let's come to the logic. Let's come to the things one by one once again. I have been given two things, n and m. N is something which I require, and m is something which I already have, right? And here I can say that let's create a function for this, which will have two parameters, n and m. N is something which I want, and m is something which I have, and I can divide it into parts. If n is greater than m, if n is greater than m, then it will be false, right? Then it would be false because the thing which I have is less than what I require. In case if n is equal to m, then that's true because I don't need to have more partitions. I can just simply take what I have because what I have is the exact same amount which I require. So I don't need to exclude or include any of the parts. I can just take all of that. Now, if that's not the case, then I will check if m is odd or not. If m is odd or even, it can have two things, odd or even. If this is odd, then you see that I cannot divide m into more parts and m is not equal to n. So basically, I cannot do anything now, and that's why I have to return false. If m is even, then what I can do, like I know that I cannot give the whole part, so I have to partition it. How can like, and I have only one choice for partitioning it, and that's into two parts of m by 2 and m by 2. Now I will compare it with n. N would either be greater than m by 2, equal to m by 2, or less than m by 2. In case if it is equal to m by 2, then what like obviously I will just give this m by 2 part and I've got what I wanted. In case if n is less than m by 2, then the other part of this m by 2 is of no use for me, because whatever I can make from both of these is something which I can make from this as well, only from this as well. And like this is like a homework for you to prove this. And like if I start proving it here, the video will become too long. That's why I'm skipping this part. Like you can prove this as well in your mind. And the other thing, if n is greater than m by 2, then obviously I have to take like some part from both of the parts. And I have to take some part from both of them. If this m by 2 is equal to 8, I have two parts of m by 2, and just imagine that I want to have total of 12. Then there are two things which you can do. Either take one of them completely and the other partially, or take some partial from here and some partial from here. है ना? So the partial which you have been skipping from here can also be skipped from here as well, because both of them are equal. And again, I don't want to go in a lot of depth here in this video. I'm going to tell you about the intuition and the approach mostly, not actually proving each and everything. So this is something again you can go in depth if you really want to prove, and realize that just taking one of these things completely and taking the other partial from the other part is better. So what I will do in case if n is greater than m by 2 is that I will take one of these m by 2, and then the new n which I will have is gonna be equal to n minus m by 2, because I have taken m by 2 already. And the remaining which I have is gonna be m by 2. So I will apply this function, and whatever this function returns is gonna be my answer. So let's write this code. First of all, I will show you my code which I wrote during the contest. As I thought that it's gonna be visible here. I wrote it wrong for the first time. I don't. Yeah, I wrote a typing. It was a typing mistake because of which it got it wrong. So here, what I did was take two inputs, and then like it is not necessary to use a while loop. I used a while loop because I was going to return yes or no from the loop itself. And here I was checking if m is odd. If m is odd, then obviously I cannot divide it. So I was checking if it is already equal or not. If it is already equal, then yes, otherwise no, and then return it. This and these are actually macros. If you go up here, you will realize that writing yes is actually writing this stuff. Cout yes. I will write the complete code. Don't worry about that. And here I've been saying that you just divide it into two parts and store whatever comes in a variable with name TP. I just named it TP because TP means time pass. Just kidding. TP is something like I usually write for top instead of writing top, and I wrote it here as well. And then I was checking if TP is equal to n. In case if it is, then just return yes. Otherwise, we will check if it is less than n or not. In case if tp, which is actually m by 2, is less than n, then subtract tp from n, which means that we are just basically taking tp, and m will become equal to tp here for the next iteration, and n is something which we have already taken care of, and it will give us the answer. So let's write the code here again. The first thing, take the header file, namespace std int main return 0. Do we have multiple test cases? Yes, we have. So we need to take this as well, and then p minus minus. Sorry. And what are the inputs here? Just two variables, int m and n. Here the inputs are m and n. We can check it here that the first line will contain m and n for every test case, and just take them as inputs. and like you can do it like the while loop which I did there, or in case if you feel some problem there in that which is a little, if you feel it a little confusing, then you can just simply write a function which will take two parameters int n and int m. If n equal to m, in that case just return true. If n is not equal to m, then what? We wrote it just a little ago. I've erased it. Anyways, just try to think about it. In a contest, you might not be writing for every question. For simple problems, you would be just writing the code directly. So, what's the stuff? If n is equal to m, then you return true. If n is greater than m, the thing which you have is greater than what you, the thing which you want is greater than what you have, then return false. If m is odd, then return false, because n and m are not equal. You have to do some operations on m, and m is odd, in, and we have already discussed that you cannot apply operations on that as well now. So int half is equal to m by 2. We would be coming to this line only if m is even. In case if it was odd, then it would have returned back here only. So after coming here, what will we see? We will see if n equal to half, in that case return true. If n is greater than half, then decrement half from n, and then return whatever you get from n which has been decremented here, and m should be replaced by half. So let's try to call this function and see what has been happening. We have been calling this function. In case if it gives true, then we will print yes. Otherwise, we will print no. Today's streak, why is it telling me again and again? Let's try to run this, and I hope it successfully runs. It gets accepted successfully. After this, we will discuss the seventh problem and not the eighth problem for now. I was not able to solve it. Okay, so we got a wrong answer. Let's try to figure out that why would have we got a wrong answer. Like getting a wrong answer is not anything bad. You will just have like you will get more practice for debugging in this manner. So what can be the mistake which we would have made? Starting from the very first line, we had to take input of that number of test cases. We did take it. Then we had to take the M and N. We took it in the correct order. So the inputs are right. Inputs are correct. After that, we have been checking if it is possible or not. Let's trust the function for now and check if the other code is correct or not. So if the code has been working properly and tells us that we can get n from m, then we are printing yes. That's what we had to do. Otherwise, we had to print no, and that's what we have been doing. So the mistake must be somewhere around here. Let's see. If n and m are equal, then I have to print true. Obviously I have to do this. So this line is correct. If n is greater than m, then I have to print false, and that's obviously again I have to do the same because m should be greater than or equal to n. If this is less, then it would give me false. If m modulo 2 is equal to 1, it means that m is odd and it is not equal to n, which I have already checked. So I have to print false once again. This is also true. Here I have been finding the half of this. This is also true. Like I have found the mistake already, but I'm still going line by line just to show you that how would you be debugging it. So then we check if n is equal to half or not, and in that case we have to return true. That's again the same thing which we have to do. If this is equal, then return true. If n is greater than half, then we have to decrement half. again the same stuff which we got in the logic, and afterwards we are just returning the function n comma half, whatever it returns we are answer. So that's also true. Then what can be the mistake? Why are we getting a wrong answer? Here, one thing which you can see is that it has been passing for three test cases and has been failing for two. So this is evident enough that either I'm super lucky that it got passed for four test cases, or I have a correct logic, but it has been failing at some edge cases. So one thing which you should be checking after this, if you think that logic is correct, is the constraints. And if you look at the constraints, you will realize that the input can be up to 10 raised to the power 18. And I have been using integer everywhere, which is not capable of holding that much. So let's convert it into long long. One of the ways to handle this is just define int by long long, and the main function should be of a 4 byte, like 4. You can just replace it by signed or maybe by a void. If you replace it by void, then remove this line, and like doing this much is good enough, and you can try to submit it. It will pass. So let's do this much only this time. The other thing which you can do is just like change this int by long long, and change these ints by long long, and this one. Changing these four parts will also get you past the code, because everything else is gonna fit an integer part. So it got accepted, and the problem we had in our code was not using long long int, and that's a mistake which happens quite a lot of times when you've been writing the code from scratch. For the fifth problem, sorry, not the fifth, but it was the seventh problem, and I think that it would be somewhere around 2400 difficulty. That's a guess from my side. You can skip this problem if you are not aware, like if you don't know how to find NCR stuff and about the factorials with modulo. Like if you're not experienced enough with taking care of these modulo stuff, and um, like you can just read the problem and you would get to know if you are able to hold up this much or not. So here you can read the problem. So please stop the video, try to think about the logic. I'm not talking about the intuition right now. Like implementation part is something I would be showing you to some extent. I won't explain everything, and we'll just show you some part, and you can do it. Like you should have to learn on your own. So I hope that you have paused the video, tried it, and now let's start. The thing which you had to notice, the first thing, you can think about this as a trick, is that if you have been given an unsorted input, and for the output part of this array is gonna be just equal to the like if the input was being given, if instead of 32553, if the input had been 23355, then the answer would be same. You have to observe this thing. So this was my first observation, that if the input had been sorted, then the answer would remain the same. So why don't I just sort the like the sort the input, whatever input I get, first of all sort it. Let's write it here. First step is just sort the inputs, because it won't change my answer. In case like it would never make my answer hard. It would either make my answer easier, or it would have no effect. As an example, if you have to find the sum of all elements of an array, and you just sort the array, your solution or your approach would never become hard, because you have been just applying one extra line. And in case of when you solve the problem, you realize that sorting was not necessary, then you can just comment that line or remove that line. So it's always a good idea to just sort in case if it has not been changing the answer. Now, the next thing is that let's take this as an example. 2, 3, I wrote it wrong, sorry. The inputs are 2, 3, 3, 5, 5. So in this case, you have to observe that if you want to take this, um, in the problem, what had been given was that we had been given the goodness for each subsequence and then we had been adding it. When I saw the problem, what came to my mind, it was because of solving a lot of problems. What came to my mind was that instead of finding all the subsequences and their goodness, I will check for every element that how many subsequences can it be treated as a like a point which has been contributing in the goodness of that subsequence. So like in a I will try to explain this. So what I thought was that instead of finding all the subsequences and then finding their goodness, I will iterate over this array, and for every element, I will find the number of subsequences in which it can come, and it would uh, act as a contributor for the goodness. So how would it act as like that? Um, let's take this one as an example, this 3 as an example. If I want to take this 3 and I want to place it at the third number, only then it would be in the condition that si is equal to I in the subsequence, the thing which had been given in the problem. In the problem, we had been given that if si is equal to I, then it will uh, this si will contribute for the goodness. So if I want this 3 to occur at the third position, I need to have two elements before this 3. As I have already sorted the array, I just need to look at the left part that how many elements are there in this subarray which has been occurring before 3, and I have to pick up 3 minus 1 number of like if this value is 3, then I need two elements before it. If this value was something like 7, then I had been willing to have 6 before it, which for which I can generalize that if I want to take an element into a subsequence, let's say if the value is x, then I want to choose x minus 1 elements before this in this subarray. And if it has been occurring at the ith index, so it means that I have I choices because 0, 1 like that. So I have I choices out of which I have to choose x minus 1 elements. And before doing this, I can check if x minus 1 is less than or equal to I or not. In case if it is greater than I, then I will say that there are no ways for choosing x minus 1 elements from I. In case if x is greater than if x minus 1 is greater than I, then I will say that there are 0 ways of doing this. Otherwise, there are this many ways. And or on the same like at the same time, I have like I can take any of the subsequences after this. I can either take none of them, I don't take anything after 3, or I take one 5, or I take the other 5, or I take both of these 5s. It won't affect this 3. If whatever I take after this 3, it won't affect this. So for this 3, it has been acting as a good index, like contributing in the goodness of a subsequence, and those number of subsequences is equal to I c x minus 1 into 2 raised the power n minus I minus 1. because these are I plus 1 words. So you have n minus I minus words, and the number of subsequences, the number of distinct subsequences they can produce is equal to n minus I minus 1. So that's why for every element in this array, first of all, first thing I did was sort it, and then the next thing I will do is traverse it and keep adding this, add this in my answer. Now, finding this part is something you have to do. Um, Finding this will take a log of n minus I minus 1 if you use a pop, like I have named the function as power mode. Like basically, finding this part can be done in log of n minus I minus 1. As an example, if you want to find the 2 raised to the power 7, so what you can do is find 2 raised to the power 1, 2 raised to the power 2, 2 raised to the power 4, and then multiply all of them. In case if you had to find the value of 2 raised to the power 13, then what you could have done is find 2 raised to the power 1, 2 raised to the power 2, 2 raised to the power 4, 2 raised to the power 8, and then um, take these three, multiply these three, and you will get it. So, like, I hope that you already know about how to implement this function, which finds this in login. I am like the log of this stuff. In case if you don't know about this, then you can study this. There are various resources available. One of them is Love's playlist, number 3 part of this, or you could go to Utkarsh Gupta's play one shot video. Utkarsh Gupta's one shot video on maths. You can find it on YouTube, and he has also explained this pretty good in a pretty good manner. And for finding this part, I did learn this from Utkarsh Gupta's video. That same video I have been talking about. You can just search on YouTube maths for CP in one video, and you would find this video maybe at the top or at the second, third spot. So finding this I C x minus 1 part is also being covered there, and I'm not going to be explaining that here. It's a little complicated for someone like me to explain, um, because it covers the topic of inversions and that stuff, which I don't think I would be able to explain. I will just write the code. So the part which you are not able to understand, you can just watch this video and you would be able to learn it from here. So are we given multiple inputs? Yes, we have been given multiple inputs. So here you would have to find the NCR multiple times, and like I'm also not very comfortable with that topic. So what I generally do is like you can write something like the maximum value can be, or like the maximum value of AI can be up till in the NCR which we had, the maximum value of I can be up to n, right? So we will create a vector of first of all, let's constant n is equal to 1e5 plus 1. The reason I declared a variable which has been having 1e5 is because otherwise I would have to write it again and again everywhere. So I just wrote it once. We will have two arrays, one of, for the implementation part. Like I have told about the intuition already. After this I'm just telling the intuition like implementation part, and I'm already telling you about this that I want to be able to explain this properly. So either you can stop the video and go to learn from Utkarsh Gupta, and in case if you want to see the implementation part part for this problem as well, then you can keep watching this video. And like you might be able to understand this, you might not be able to understand this, so you have to go there in case if you fail. Mm. So we will create two integer arrays. One of them would be int fact. It will here fact I will have the factorial of uh, integer I, and v fact n plus 1. So this is something I don't think I would be able to explain, so I'm just skipping this part from explanation. Generate factorials. I've been creating a function which I would call here, and it will like generate all the factorials. So fact of 0 is 1, we already know. After that, we will apply a loop from I is equal to 1 till I is less than equal to n, where fact of I is equal to fact of I minus 1 into I. And then I will say that like I need I need to find the inverse factorials as well. So and v fact of n is equal to inverse of fact n. Oh yeah, by the way, we have been taking a lot of, we would be taking modulo a lot of things. So let's declare constant mod is equal to 1e9 plus 7. And let's declare this uh, inverse function. So int, by the way, the value of n might sometimes go outside the integer range. So to keep things easy for us, let's define int as long and change it to sign. And here declare the inverse function, which will take a number as input. Let's say it to be a or num, and we will return the power mod function of this, or maybe let's declare power mod of num mod minus 2 mod. I don't remember the name. I don't remember the names, but that's how we find the inverse of a number. And we have to declare the power mod function as well. So in this power mod function, it will tell a cover b, and we can write it something like this. If b is equal to this, then this is equal to this into a mod b divided by 2, a is equal to a into a mod, and then return this, and like everything is sorted here. After this, we have to find the inverses as well. I is equal to n minus 1 till I is greater than equal to 1, I minus minus. For inverse no, inverse fact of I, it is equal to um, like this inverse of like fact I is equal to I factorial mod. This is something like this, and inverse fact I is like the modular multiplicative inverse. I'm not really willing to go into that topic right now, but just to tell about the thing which I'm going to write, this is something like this: n factorial is equal to n into n minus 1 factorial. So here I want to find this value. I know about n factorial and n. So for finding n minus 1 factorial, I can say that nahi, I'm willing to find 1 upon n minus 1 factorial, so I can write it as n into 1 upon n factorial, and this 1 upon n factorial is inv fact n. Basically, it's not exactly like that, but you can understand it to be similar to that. It is like, again, I'm not really willing to explain all that part. I'm also not really comfortable in that thing. You can watch that video. He has explained it pretty well. So um, here I can, like, what I have said is that 1 upon I factorial is equal to I plus 1 into 1 upon I plus 1 inverse. This is the thing which I have written here. And the factor of 0 is equal to 1. I think that I could have taken it till 0 here, but anyways, doing it like this will create much of a difference. And here I need to have an NCR function which will take n and r as input, and it will tell me the NCR. So what is NCR? I hope that you already know about this though, but still, NCR is equal to n factorial upon r factorial and n minus r factorial. So we will write this n factorial, which is fact of n. Oh yeah, by the way, we made one mistake. We have to take modulo everywhere because otherwise it will get out of the range. It will go out of integer range. That's why we have to take modulo everywhere. And we have taken modulo here everywhere. So that's it. That's good. We will multiply factorial of n into inverse factorial of r, as you see here, inverse factorial of r, and then take mod and multiply with in fact of n minus r, then again take mod, and that's it. It will give me NCR. So now let's come to the implementation part. All this was pre-computation, and this was a complicated part in the implementation. So if in case you have not studied all this, then you will have to study this for solving this problem. And for those who have studied this, the problem is pretty straightforward afterwards. You just take the inputs. So let's take inputs. And I less than I plus plus C and R and N. And then we will do is what we will do is sort ARR AR plus N. And then we have to create a variable, let's say as answer. And we will go to each and every element in this array. We will do some stuff, and at the end we will return answer in which we will be having our answer. So what I have to do, I will find um, this curve will store, like here I will write some code in this for loop for every element. What I'm going to do is find the contribution of this element in the goodness in the variable cur, and here I will say that answer is equal to answer plus cur mod mod. So I have to write some code to find cur here. What will be the value of cur is something like we wrote it just before a few minutes ago that I see x minus 1 if x is the current value of the element, if I x is the value of the current element, into 2 raised to the power n minus I minus 1. So this power mod, this power stuff, let's write it as here that this um, let's call it as PW. I just don't want to take any keyword, that's why I'm taking some. random names. Let's take its PW physics wala, and it will have power mod of 2 की power n minus I minus 1, and like this is after, this is on the right side. This is the all the choices I have for the right side. On for the left side I have the choices as, oh yeah, let's write the condition here, that if n is less than r, return 0. I'm getting a call, just a few. Yeah, so sorry for the delay. Is it recording? Yes. So here, if n is less than I, if n is less than r, then I am returning 0. And here I've been saying that for the left part, the number of choices I have is equal to, um, on the left side, I have I variables, and the number of variables I want to choose is equal to ARR of I minus 1 on the left part. And afterwards, here the I can replace cur by left into right and take its modulo, or maybe let's keep the things simple. To keep it clean, I have been writing things like this, that int cur is equal to left into right modulo mod, and then just add these things. So let's see if it has been working or not. In case if it doesn't work, then we will debug it once again. Debugging is really important. Like making mistakes is okay at the time of practice, because you want to upsolve more and more. Um, you want to debug more and more, and you want to समझ जाओ यार बता सकते हो. Yeah, so it passed. I had been planning to make a small video, but I think the video got too long, so I'm sorry for that. At first, I was just thinking of explaining all the intuition of the problems and the approach, but uh, while making the video, I thought that some of the problems had really simple logic. So if someone had been failing to solve the problem, then he must have got stuck at the implementation part, and that's why I have been solving that as well. So thank you for watching the video, and bye bye.